Welcome. You are experiencing a unique two-host AI conversation powered by Google's Notebook LM, designed for deeper, more dynamic analysis of essays and texts.
We're here to get into the very structure of the ideas that have shaped our world.
And looking at our topic today, I have to say I'm genuinely intrigued.
It's a pleasure to be here. And intriguing is definitely the right word. We're tackling a subject that sounds so basic on the surface.
Nearly does.
But the moment you scratch it, you realize you're standing on the edge of a very deep philosophical abyss.
We are looking at Mortimer J. Adler's essay on element from the great ideas Syntopicon. And I'll be honest, when I first saw the title, my brain just immediately went to high school chemistry.
The periodic table.
Exactly. The periodic table, the little squares, maybe a Bunsen burner. I really thought we were going to be talking about carbon and helium for an hour.
Common assumption.
But reading through Adler's essay, this feels like something else entirely. This is not just a chemistry lesson, is it?
Not at all. In fact, if you're only thinking of chemistry, you're missing about 90% of the story.
Wow.
This is a 2,500-year-old detective story. It's the story of humanity asking one single persistent question.
Which is?
What is reality actually made of? And Adler takes us on a journey that goes way beyond just physical matter. He's looking at the structure of thought, of language, music, logic.
That was the hook for me. Adler frames element as this universal tool we use to fight back against chaos. The world is messy, it's complex, it's completely overwhelming.
And so we have this fundamental drive to break it down.
To find the simple blocks that build the complex whole.
Precisely. So our mission for this deep dive is to explore exactly how we, as a species, try to find the simple within the complex. We're going to look at how we analyze the world, break it down, and try to find the absolute bottom.
And just to be clear for everyone listening, our source material is specifically Adler's essay on this topic. It's a sweeping text.
It is. It touches on ancient Greek philosophy, medieval medicine, geometry, and it goes all the way up to modern nuclear physics.
It covers all these distinct domains like physiology and grammar, not just physics. So let's unpack this. Adler starts with a definition, and I found it surprisingly broad.
It is, isn't it?
He defines an element as the smallest component into which anything can be analyzed, and from which it can be reconstituted. Analyzed and reconstituted. That sounds a little technical.
It's technical, but the logic there is critical. It's a two-way street. Analysis is taking the whole thing apart to find the pieces.
Right, breaking it down.
But reconstitution is the proof.
Yeah.
It means you can take those pieces and build the whole thing back up again. If you can't rebuild it from the parts you found, you might not have the true elements.
Okay, that makes perfect sense. If I smash a vase with a hammer, I get a bunch of parts, but there's no way I can reconstitute the vase. So those shards aren't really elements in that organized sense.
Exactly. Adler uses some great examples to clarify this, examples outside of just physical objects. He brings up language.
Language is the perfect starting point.
It is. Think about a word. Let's just take the word cat. You can analyze that word down into its components. What are they?
C, A, and T. The letters.
Right. In the domain of written language, letters are the elements. Now, if you were talking about spoken language, it would be the phonemes, the sounds.
Okay.
Now, shift that to music. You listen to a symphony. It's complex, emotional, sweeping. But what is it actually made of?
Tones. Individual notes.
Exactly. Tones are the elements of melody. And if you look at the physical world, the ancients argued that simple bodies, fire, water, earth, air, were the elements of all physical matter.
So the pattern is the same in every single case. You have a complex whole, and you apply analysis to break it down until you hit rock bottom.
You got it.
But this is where I got a little stuck for a second, and I want to push on this. Adler brings up this nuance about indivisibility. He says an element is the limit of analysis. But is it really?
What do you mean?
Well, let's take the letter A from our cat example. If I write a giant letter A on a piece of paper, I can physically cut that paper in half. I can divide the A.
That's a fantastic point, and it gets to the crucial distinction Adler is making. An element does not have to be absolutely indivisible in every possible sense.
It doesn't.
No. It just has to be irreducible within its own domain.
Within its own domain. Okay, explain that.
Let's go back to your letter A. You've cut the paper in half. You have the top part of an A and the bottom part.
Mm-hmm.
Do you have two smaller letters?
No, I have junk. I have unintelligible scribbles.
Exactly. You've left the domain of language, and you've entered the domain of, say, physics or geometry. In the domain of language, the letter A is the floor.
You can't go any lower.
You can't divide it and
Right.
still have a unit of language. Therefore, in that context, it is the element. It's the limit of analysis for that specific system.
That is a really helpful way to frame it. So it's context dependent. A lawyer might look for the elements of a crime, the specific actions that have to be proven. He's not looking for carbon atoms in the defendant. He's looking for the irreducible legal requirements.
Correct. We're always looking for the simple that constitutes the complex. But what simple means changes depending on what game you're playing.
Okay. Now, before we dive into the historical cage match between the element guys and the atom guys, because it really does feel like a fight, Adler gives us a conceptual framework.
He does.
He distinguishes between three terms that I have to admit I feel like I use interchangeably all the time: element, principle, and cause.
This is a bit of heavy lifting, I'll grant you. It's very Aristotelian,
Yeah.
but sticking with it really pays off. Adler breaks it down like this. An element is a component that is immanent in the thing.
Immanent, meaning it's inside the object.
Yes, it's the part the whole is made of.
Okay.
The flour in the cake, the brick in the wall.
Got it.
Now, a principle is the source from which consequences derive. It's the starting point of a process or a change.
Okay.
And a cause is the origin from which effects result.
I'm going to be honest. Principle and cause sound identical to me. Source from which consequences derive versus origin from which effects result. That feels like splitting hairs.
It is subtle, but think of it this way. The very same thing can be all three, depending on your perspective. Let's take a classic example. A bronze statue of Hercules.
Okay, I'm visualizing a bronze statue.
If you look at that statue standing there and you ask, what is this composed of? The bronze is the element. It is the material part that is immanent in the statue.
Right, that's what it's made of.
Now imagine the process of making the statue. The sculpture starts with a raw lump of bronze. That raw lump is the beginning of the change. It's a starting point. In that sense, the bronze is the principle of the becoming of the statue.
Okay, so principle is more about the timeline. It's the start of the process.
In this case, yes. And finally, if you ask, what is responsible for this statue existing? Well, without the bronze, there's no statue. The bronze is the material cause. It's the origin that allows the effect to exist.
So it's really about the angle of your analysis. Are you asking, what is it made of, which gives you element?
Right.
Where does the change start, which gives you principle? Or what produced this effect, which gives you cause?
Precisely. And keeping those distinctions in mind really helps when we look at the ancient Greeks, because they were obsessed with that first question. From what do all things come?
And this brings us right to section number 2 in our outline, the great debate, elements versus atoms. And I think most people today think element and atom are just synonyms.
They do.
You know, atoms are the elements. But Adler makes it crystal clear these were rival gangs. These were fundamentally opposed views of reality.
They absolutely were. This debate defines the history of Western science. On one side, you have the theory of elements, which is qualitative.
And on the other side,
You have the theory of atomism, which is quantitative.
let's start with the qualitative side. This is Plato and Aristotle. And I have to say, reading through Adler's summary of Aristotle, his view feels so much more intuitive to how we actually experience the world.
It is intuitive because Aristotle started with his senses. He didn't have a microscope. He looked at the world and asked, what are the most basic qualities I can feel?
And he landed on 4.
He identified 4 primary qualities: hot, cold, dry, and moist.
And these combine to form the classic 4 elements we see in movies and fantasy novels.
Right. So fire is the combination of hot and dry. Air is hot and moist. Water is cold and moist. And earth is cold and dry.
And the genius of this system, and I do think it's genius because it solves a huge problem, is that it explains change.
It does. It explains transmutation. Because the elements share qualities, they can actually turn into one another.
Walk us through that. How does, say, water become air in this model?
Well, just look at the qualities. Water is cold and moist. Air is hot and moist.
So they both show the quality of moisture.
Exactly. So if you apply heat to water, you are driving out the cold and replacing it with hot. The moisture stays put. So cold and moist becomes hot and moist. Water becomes air.
That's boiling. That's evaporation.
Exactly. Yeah. To Aristotle, he wasn't seeing molecules speeding up. He was seeing a quality exchange. The cold was fleeing and the hot was entering.
It makes perfect logical sense if you're just using your own eyes. You see ice turn to water, water turn to steam. It really does look like the elements are morphing into one another.
And Plato took this a step further, adding a mathematical layer. He argued that the elements were bound by geometric ratios.
Ratios.
Yes, he said something like, as fire is to air, so is air to water, and as air is to water, so is water to earth. It was a vision of this harmonious, interconnected cosmos where qualities just flowed into one another. It's a very poetic, beautiful universe.
It is. But then you have the rebels, the atomists, Leucippus, Democritus, and later the Roman poet Lucretius.
And they looked at all this quality stuff, this idea that hot is a real existing thing, and they said, no.
They took a hard turn toward the quantitative.
Very hard turn. The word atom comes from the Greek atomos, which means uncuttable. Their argument was purely logical. There must be a fixed limit to the breaking.
You can't just keep dividing matter forever and ever.
Right. Eventually, you have to hit a bottom. You have to hit a solid singleness that cannot be divided any further.
And here's the key difference that Adler highlights. And this is where I think the atomists get a little scary philosophically. For the atomists, these little particles don't have qualities, do they?
No, they do not.
Yeah.
And that is the radical leap. They argued that atoms only differ in quantity.
What does that mean, quantity?
They differ in size, shape, weight, and their arrangement. An atom of fire isn't hot on the inside. It's just small, round, and fast-moving. When a bunch of them hit your skin, that speed and shape create the sensation of heat.
So an atom of iron isn't inherently hard or gray.
No, it's just hooked together very tightly with other atoms of a certain shape. It implies that the world we actually experience, the redness of a rose, the taste of wine, the coldness of snow, is, in a way, an illusion.
An illusion built by our senses. Democritus had that famous quote. I wrote it down. By convention sweet, by convention bitter, by convention hot, by convention cold, by convention color, but in reality, atoms and void.
It's a chilling quote, really. It strips the world of all its texture. It says that underneath it all, reality is just geometry moving in the dark.
Atoms and void. That leads us directly into the next big battlefield.
Yeah.
You cannot have atomism without the void.
This is section number 3, the battle over the void. The void is a necessary partner to the theory. Lucretius stated it as clearly as possible. Nature is founded on two things, bodies and void.
Why is the void so important? Why can't you just have atoms packed together like sardines in a can?
Movement. If everything is packed solid, what philosophers call a plenum, how can anything possibly move? Where would it move to?
There's nowhere for it to go.
Exactly. If I want to walk across the room, I need empty space to move into. The atomists argued that for atoms to rearrange, to crash into each other, to form new things, there must be empty space, a void for them to move through.
That seems obvious to me. It's like one of those sliding tile puzzles with one square missing.
Perfect analogy.
You can only move the tiles because of that one empty square. If you filled that square in, the whole thing would be frozen. Nothing could move.
The void is the empty square. It allows for change. And it also explains density. Why is a rock heavier than a piece of wood of the same size?
Because the wood has more void in it. More empty space between the atoms.
That's the argument. It explains porosity. It explains divisibility. You can cut an apple because there is void between the atoms for the knife to pass through. You can't cut the atom itself because it has no void inside it. It's solid singleness.
But not everyone bought this. Adler introduces René Descartes as the heavyweight critic of this entire idea. And Descartes, well, he hated the idea of a vacuum. He hated the thought of nothingness actually existing.
He did. Descartes was a pure rationalist. He argued from logic alone, not just observation. For Descartes, the very definition of matter was extension taking up space. So if something takes up space, it is matter. Therefore, the phrase empty space is a contradiction in terms.
Wait, walk me through that again. If I have an empty box, I say it has space inside. Descartes is saying that space is matter.
Yes. He would ask you, does the inside of that box have height? Yes. Does it have width? Yes. Does it have depth?
Yes.
Yes.
Worse.
Well, if it has dimensions, it is an extended thing. And if it's an extended thing, it is matter. To Descartes, saying there is a nothingness that has dimensions is like saying there's a square circle. It is logical nonsense.
So for Descartes, the universe is a plenum. It is continuously filled. There are absolutely no gaps.
Correct. A full universe.
So how on earth did he explain movement? If there's no empty tile in the puzzle, how does anything move?
He viewed the universe more like a liquid. If you move your hand through a swimming pool, the water flows around your hand to fill the space behind it instantly. It's a vortex. Descartes believed all motion was a kind of circular interchange.
That is wild. And this leads to his argument against the atom itself. Descartes argued that matter must be infinitely divisible.
He basically challenged the atomists to a thought experiment. He said, tell me there's an atom, and I will tell you that in my mind, I can imagine dividing it in half.
And if you can imagine it, it must be logically possible.
Right, because matter is just extension, and you can always mathematically divide a length in half. You can take the number 1, divide it to 0.5, 0.25, 0.125. You never hit an absolute zero.
There's no logical point where you have to stop.
So he argued that uncuttable atoms are impossible in thought. God wouldn't create something that he himself couldn't split.
So we have these two absolute heavyweights, the atomists saying you have to stop cutting somewhere or reality just dissolves into nothing, and Descartes saying math proves you can divide forever, so atoms are a myth.
That is the standoff. And it really does frame the entire history of physics. Is reality discrete, made of indivisible blocks, or is it continuous like a fluid?
Before we jump from these ancient and Renaissance debates into the modern scientific revolution where things really start to get explosive, I think we should take a breath. This is some heavy stuff.
It is good to pause and let these concepts settle in.
Before we jump into that modern scientific revolution, let's take a pause for mindful moments. Our YouTube channel offers AI book analysis, summaries, and critiques, all designed to inspire reflection and rational thought. It is a great way to keep feeding your brain while you are on the go.
Indeed. Reflection is definitely key.
Okay, we are back. We have been talking about physics, rocks, fire, the void, but Adler points out that this concept of element wasn't just confined to dead matter, it went straight into the human body.
Yes, this is section number 4, elements in physiology.
This connects the 4 elements of physics directly to the 4 humors of medicine.
It does. This was the dominant medical theory for almost 2,000 years, championed by Hippocrates and later Galen.
And the mapping is just, it's too perfect. It feels like they really wanted the universe to rhyme.
The symmetry is incredible. They believed the body contained 4 primary fluids, or humors, that corresponded directly to the 4 elements. So you had blood, which corresponded to air. Remember, air is hot and moist.
Okay, blood is air. Got it.
Then you had phlegm, which corresponded to water, so cold and moist. Yellow bile corresponded to fire, hot and dry. And black bile corresponded to earth, cold and dry.
And a person's health was basically just a mixology problem.
Exactly. Health was the proper balance or proportion of these different mixtures. Illness was an imbalance. If you had a fever, you're too hot and dry, you might have an excess of yellow bile.
And if you were lethargic and congested, cold.
You had too much phlegm. So the doctor's job wasn't to kill a bacteria he couldn't see. It was to rebalance your personal elemental cocktail.
Which is why they used things like bloodletting or induced vomiting. They were trying to literally drain the excess humor to restore the proper balance.
Correct. It was all about equilibrium.
And this is where we get words we still use today to describe personality, right? I mean, we still call people melancholy.
Yes, the temperaments. If you had a surplus of blood, you were sanguine, cheerful, optimistic, maybe a bit flighty.
The life of the party.
Right. Too much phlegm made you phlegmatic, calm, unemotional, maybe a little lazy. Too much yellow bile made you choleric, angry. Short-tempered, a natural leader.
And too much black bile
made you melancholic, sad, depressive, often poetic.
It's just fascinating how deep the element concept went. It wasn't just, what is this rock made of? It was, what is my personality made of? It shows that human drive to find the building blocks of everything, even our own feelings.
It was a unified theory of reality. The microcosm of the human body was a perfect reflection of the macrocosm of the universe. If the universe is earth, air, fire, and water, then I must be earth, air, fire, and water too.
But as with all unified theories, eventually someone comes along and pokes a giant hole in it.
And that brings us to section number 5, the modern revolution. The man who really ruined the party for the 4 elements. Antoine Lavoisier.
Lavoisier, the father of modern chemistry.
For a very good reason. In the late 18th century, he looked at the 4 elements theory and essentially said, prove it. He called it a mere hypothesis.
So he was skeptical.
Very. He said the idea of earth, air, fire, and water was assumed long before experimental philosophy even existed. He proposed a new operational definition of an element. And this is a crucial turning point in the essay and really in human thought.
Operational meaning based on what we can actually do in a lab, not just what we think about philosophically?
Precisely. Lavoisier defined an element as any substance we cannot currently decompose.
That's a very humble definition.
It's epistemologically humble, isn't it?
Yeah.
He's saying, look, I have this substance, I have boiled it, burned it, reacted it with acid, and I simply cannot break it down into anything simpler. So for now, I am calling it an element.
But he leaves the door wide open. He's admitting, maybe tomorrow, someone with better tools will find a way to break it.
Exactly. And this just exploded the list of elements. Suddenly, air wasn't an element. He proved it was a mixture of oxygen and nitrogen. Water wasn't an element. It was a compound of hydrogen and oxygen. The list went from 4 to dozens very, very quickly.
So we moved from this poetic world of 4 qualities to a rigorous, growing list of chemical ingredients. But what about the atoms themselves? Lavoisier is dealing with chemical substances. Did the physicists stick with the hard, solid atom?
For a while, yes. And this leads us to section number 6, shattering the solid atom. For that, we have to look at Isaac Newton. Newton was what you'd call a moderate atomist. He gave us the classic billiard ball view of the universe.
Adler quotes Newton in the essay, and it is such a strong, vivid image. Newton wrote that God formed matter as solid, massy, hard, impenetrable, movable particles.
He goes on, even so very hard as never to wear or break in pieces. That was Newton's view. The universe was made of these indestructible little rocks bouncing off each other according to precise mechanical laws.
It's a very reassuring, solid view of reality. It feels stable. You can build a clockwork universe on that foundation.
You can. But then Michael Faraday comes along in the 19th century and things start to get weird.
Faraday brings electricity and magnetism into the picture.
He does. And he starts looking at how atoms behave, specifically in electrochemical decomposition. And he realizes the billiard ball model just doesn't quite work.
How so? What was the problem?
Faraday challenges the very idea of solidity. He proposed that atoms are not hard rocks, but are instead centers of forces or powers.
Centers of force. That sounds like something out of science fiction. It doesn't sound like matter at all.
It's much closer to modern quantum field theory than it is to Newton. Faraday asked us to visualize atoms not as things with hard, definite edges, but as fields of influence. He described them as highly elastic and mutually penetrable.
Wait, mutually penetrable, so 2 atoms can pass right through each other.
If they're waves or centers of force, yes. Think of 2 ripples on a pond. They don't bounce off each other like billiard balls. They pass through each other, they interfere, they combine and separate.
This dissolves the solidity of matter entirely. We went from the solid singleness of Democritus to mutually penetrable powers.
It does. And Adler emphasizes this shift as being monumental. We move from the uncuttable solid of Democritus and Newton to the energy field of Faraday. It implies that matter, at its most fundamental level, isn't really stuff in the way we think of it. It's power, it's activity.
That is mind-bending. And it leads us right to the big unresolved question in section number 7, the unresolved philosophical question. Because, look, we have split the atom. We found electrons, protons, neutrons. We found quarks. Science seems to have answered the question, is matter divisible? And the answer is yes, it is.
But Adler would say, not so fast.
Yeah.
We have to make a very clear distinction between what science solves and what philosophy asks.
Explain that. If we split the atom, didn't we prove the atomists who said it was uncuttable wrong?
We proved that what we called an atom was, in fact, divisible. But the fundamental philosophical question remains, is there a bottom? Is matter infinitely divisible? Or will we eventually hit a final, fundamental unit that absolutely cannot be divided?
I see. So even if we manage to split a quark and find something inside it, the same question just reappears. Is the thing inside the quark divisible?
Exactly. Adler argues that science, by its very nature, cannot answer this question because we can't perform an infinite number of divisions in a laboratory. We can only divide as far as our current technology allows.
So the question, is reality continuous like Descartes thought? Or is it discrete like Democritus thought, remains a philosophical debate.
It's a logical problem, not just an experimental one.
That is a really important distinction. Science answers, how far can we go right now? Philosophy asks, does the road ever actually end?
Precisely. And this ties directly into the metaphysical stakes of the whole debate. Adler touches on the conflict between materialism and dualism.
Right. Because if you're an extreme atomist, like Lucretius or later Thomas Hobbes, you believe that everything is atoms.
Yes. For them, the soul, the mind, your thoughts, they're all just subtle, fast-moving atoms bumping into each other in your brain. There's nothing else, just matter in motion.
But then you have the moderate atomists, people like Newton or John Locke.
They accepted atoms as the perfect explanation for physics, for rocks and planets and tables, But they denied that the soul was material. They held a dualistic view. Matter is atomic, but the spirit or mind is something else entirely.
So the concept of the element forces you to decide what you think the universe ultimately is. Is it just a very complicated machine? Or is it a machine with a ghost in it?
And that fundamental question has not been solved by finding the Higgs boson.
So what does this all mean for us today? We're at section number 8. Why this matters. Why should a listener who maybe is a programmer or a musician or just someone trying to get through their week care about this 2,500-year-old debate?
Because the idea of the element is a tool for thinking. It's about the universality of analysis. If you're a programmer debugging code, you are looking for the element, the single line of code, the one faulty function that's causing the entire system to crash.
And if you're a biologist, you're looking at DNA base pairs.
Yeah.
If you're a business analyst, you're breaking a supply chain down to its individual components to find the bottleneck.
We are all doing what the Greeks started. We are all looking for the simple blocks that build the complex whole.
We have to. We can't deal with pure chaos. We have to structure the world.
Exactly. The great idea here isn't any single answer. It's the search for order itself. It transforms how you look at the world, not as a chaotic, incomprehensible mess, but as a structure built from fundamental, understandable parts.
It empowers you to take a big, scary, complex problem and say, okay, what are the elements here? Let's just break it down.
Analysis is always the first step to understanding.
And I think there is a fascinating takeaway from the scientific evolution we discussed. We started with the 4 tangible elements, moved to solid little rocks, then to invisible billiards balls, and we ended up with vibrating, interpenetrating force fields.
It seems that the deeper we look, the less material the world actually becomes.
Which leads me to a final provocative thought for our listeners. We usually think of materialists as people who believe in hard facts and solid, tangible reality. But if modern science suggests atoms are mostly empty space and fields of force, just as Faraday started to imagine, does that mean the materialists were wrong about the very nature of reality itself?
That's a great question.
Are we living in a world of solid singleness, as Democritus believed, or are we living in a world of interpenetrating powers? When we touch an object, are you touching a solid thing, or are we just interacting with fields of energy that repel each other?
That is a question that certainly keeps the philosophy departments and the physics labs very busy.
Something to chew on next time you touch a table. Is it really there?
Or is it just a center of force powerfully repelling your hand?
I love it. Well, that is all the time we have for On This Deep Dive.
It has been a fascinating exploration.
Click the link on screen for more on this and other essay subjects. Subscribe, share, purchase via link, and think rationally.
See the many genre-based book podcasts at Mindful Moments. Nourish your mind on the go.